right, so remember IP is going to get you across the network. Okay? So IP is what gets the packet across the network. And we remember, as we just said, DNS is a separate thing. All right, so here I am with my client. And we know things like, there's a switch. We know there's a router. There's probably more switches. Anyway, lots of routers. Routers and routers and routers going across the network. Okay, so we understand that this is layers 1 through 3. Okay, so in theory you might think, oh, well then we're done. I got from my client, we'll just put our client here. So this is our client host to the server host. So we're done. But we are not done. The problem is now, once we got to the host, there are actually multiple applications that could be running here. Okay? Oops, it doesn't look very good. Sorry. So I might have a web browser. I might have email. And I need to be able to say, what program is this data going to? Right? So here's our packet. Inside the packet, remember, is the data. And I need to know, where is that data going to? That is my question. Are we good here? That's one of the big questions of our next layer, which is TCP. Oh, oops. Sorry. The transport layer actually provides the service between applications. Oh my goodness, application to application connection. All right? So if this is indeed web, and I've sent a web message, the TCP layer is the thing that gets it to the right place on the server. Your client can run multiple applications. The server can serve multiple clients. Okay? And TCP is what does it. So remember, here I am on my web browser connecting to the web server. And I already know that when the reply comes back from the server, that was this packet, my computer has to decide it's for web, and they have to know where it goes. The server needs to be the same way. It needs to be able to keep, even within the web application, it has to keep track of which client goes with which connection. So which client gets what data. Are we good here? Everyone that hits CNN.com at the same time is getting a different website back, or a different page back, okay? It's the same computer though, but it has all these different people connected to it. The transport layer is what gets that done, all right? Here's how it works. What we're talking about here is the transport layer, okay? Layer was, what layer was this? We are at layer 4 now. So we just finished up layer 3. Now we're moving on to layer 4. This will be, I think I drew this diagram last time. So I've got a nice client here with their keyboard. We understand that on the client, they can be running multiple applications. So I'll draw those out with my little floppy disk. Okay, so this might be web And let's say, I don't know, maybe I'm running Skype. Okay. So I understand I can talk to someone using Skype and use my internet or my web browser at the same time. Even though there is one cable running in here, running to switch, routers, lots of stuff in between. And let's go over here to our server. And let's say this is a web server. All right. And that looks great. Okay, so the stuff we've been through is to get from one host to another, all I need to get to is layer 3. So layer 3 handles all of that stuff. All right? The issue here is to get between applications. So the application-to-application communication, this is one of the functions of layer 4, and we'll see some of the other functions in a minute. All right, so we understand, right, when I encapsulate my web message and I send it along the way inside frames and more frames and inside packets, etc., it needs to be able to get to the web server. That's very exciting. If I have a Skype call going, that's my lovely green there, they're going to go down the same cable. The frames are going to look much the same. Let's go up this direction. But it's eventually going to get to whoever I'm talking to. Okay, we'll put them here. Okay. So my Skype buddy, FaceTime buddy, whatever you want to call him there, okay? So my computer, in order to sort out as traffic comes back from the web server, it comes over the same cable. It has my IP address on it, but it's the transport layer that switches between the two. Just to note at this time also, we think about a web server. The web server has to also keep track of the different traffic of different people. So my traffic's coming in, I drew those lovely red ones. So what about the blue traffic? The web server itself, the application, needs to know the red is, I don't know, we'll call this person John. And the green is, they're supposed to go with Alice and Bob, sorry, Alice, okay? I guess I'm Alice, sorry. So Alice over here is red traffic, John is blue, and the web server has to be able to keep track of it too. The transport layer also does that. So how does it do it? It's actually pretty cool. So if we look at a TCP segment, and remember this was, so we have our application, and it goes into the next layer. We have our application, and then we put on here TCP. This is the TCP segment, okay? So the TCP segment, here we go. The fields look something like this. If we start over here at bit 0, over here at bit 31, we have a source port. I'm going to write these a little bigger because I don't know. A source port, this is 16 bits long. And we have a destination port, which is also 16 bits long. Right? There's a bunch of other stuff down here, and I'm not going to get into it right now. But the thing we want to know is, what are these fields used for? So what do they mean? All right? So first question, what is a port? Did you guys get that down? So this is the first things that come off the TCP segment. Okay. Applications communicate via ports, okay? So a port, you know, it's like a port, right? So if we imagine like my computer, this is kind of a funny way to think about it, but if we had like here, you know, there's ports on it, right? There's little ports. These are like virtual ports though, okay? So each application is going to have its own port, app 2, app 3, blah, 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 all right? This is virtual ports. If I'm a server, I'm going to open a port for listening. So we'll draw our server again here. And let's say this is a web server. And look at that 3D. So I'm going to draw an ear on this because this is where I'm listening. And I can then send stuff. If I want to send something to the server, I send it to the open port. So the web server is listening on port, and this is port 80, in case you're interested. A web server listens on port 80, and they're just sitting there waiting for people to send it things to port 80. So here's what I would do. If I was a client over here with my lovely computer, and I'm looking at the screen, and my computer's IP address is 60.171.18.22, and I wanted to connect to a web server, and we remember from last time that the name I typed in just matches to an IP address. So let's say this is the IP address I want to send web traffic to. What I need to do is then, we already understand I can send a packet, right? Packet from 60 to 1, or 60.171, all that, to 1.33. We're okay with that. But now we need to know the port number because that's the specific application I'm going to. So I'm going to say from 60.171.18.22, and I'm going to say port, and right here I'm going to pick actually a more or less random number, 50047, okay? It's like my special message to the server. I'm going to go to the server, 1.33.17.13, and the server's port, as we already said, is port 80. All right? So that's sort of the total message. Now we remember from our IP section, this number, the IP address, is in the packet. It's on the packet. The port number is on the TCP segment. Okay? That's what we just showed you here. Okay? Destination port was 80 here. Source port was 50047. Okay? Okay? And again, the web server, when I started up that web server application, the web server application already was configured to listen on port 80. And so the application, as it was running, it just opened up port 80. If this ever happens on your computer, your firewall will tell you, is it okay for whatever application to use port 80? And you might have to type in an administrator password or something. Okay? I have a web server on my computer at home, and like I said, whenever I start it up, it says, enter your administrator password. I got a really locked down firewall, so enter your password to open port 80. Okay? So again, the web server is just sitting there. Remember, my client over here, my web browser, is not listening for anything. So this random port number, it opens this sort of random number because now it has that port open while at least they're talking. And let me just scoot this up. And let's think about it going back. This is when our thing gets bad. So I got the server here, And we're going to use the same IP address, but I'm not going to write it out, sorry. And we're going back. So this is the reply. The server sends back the web page I asked for. Now it is from the server, 1.33.17.13. It is on port number 80. You guys see port 80 right there, right? It is to my computer, 171.18.22, on port 50047, okay? So there's my big old message from the server back to me. All right? So we walk through it again. When I open the web browser, by default, web browsers are port 80 anyway. So when I'm just using my web browser, I type in, I don't know, cnn.com, get their IP address. My computer sends a packet from my computer. It picks a random number for its source port. It sends it to the web server on port 80, because that's by default what a web server listens on. When the web server gets the request and it sends the response back, it uses the same, this is a connection now, it uses those same two ports, okay? But it reverses them. Now the source port is 80 and the destination port is 50047.